This video we're going over the Chapter 4 test, at least the proof section of it. First question says, given AB, that segment is parallel to segment DC, and that AB is congruent to DC, prove that triangle ABC is congruent to triangle CDA. So we know this top segment is congruent to the bottom segment, and they are also parallel. So your first reason should have been given. AC is congruent to AC. Well, whenever something is equal to itself, that's reflexive. Okay. Now they tell me the angle BAC, this angle here, is congruent to angle DCA, which is that angle there. Now we got to determine why are they congruent. Well, let's look at the lines that form them. That line there, that line there are parallel. They're then cut by that yellow transversal. So this angle and that angle should be congruent because they're alternate interior angles. If two parallel lines are cut by transversal, then alternate interior angles are congruent. That should be the reason. Just to save some writing, I'm just going to write alternate interior angles congruent. And then that leads me to triangle ABC congruent to triangle CDA, and the reason those two triangles are congruent is side, angle, side. Looking at question number 2, we know that QS, that segment bisects angle RST, and angle R is congruent to angle T. They've already gotten that drawn in for us, angle R congruent to angle T. My first reason obviously is given. Now, why is angle RSQ? Why is that angle right there and that angle right there? Why are they congruent? Well, we were told that QS bisects the angle RST. So the reason there is the definition of an angle bisector. Remember, angle bisectors take an angle and they cut it into two smaller congruent angles. QS is congruent to QS, number 7. Again, something's equal to itself or congruent to itself is a reflexive property. And now what we have is this image here. So we've got an angle congruent to an angle, another angle congruent to another angle, and a side congruent to a side. So you got angle, angle, side up top, angle, angle, side on the bottom. So now that is my reasons for step 8, angle, angle, side. And now they ask you, well, then how do you know that QR and QT are congruent? Well, QR is the first 2 letters in that name. QT are the first 2 letters in that name. So they're corresponding parts. So my reason is CP, CTC. Corresponding parts, congruent triangles are congruent. Moving on down to question number 3. They tell us angle E is congruent to angle K, angle DGH congruent to angle DHG, and segment EG is congruent to segment KH. Prove the 2 triangles out here. That triangle there is congruent to that triangle there. Okay. This shouldn't be extremely difficult to do. We've already got this angle and that angle congruent. We've got a side congruent to a side. So far we got angle side. It would be nice if you could learn that this angle here and that angle there are congruent, and then you have angle side angle. So that's the goal that we're going to have in mind as we go through this. First thing you want to do is look at obviously your given should be written in, but they talk about 2 angles up to 180 degrees. So I want to look at those 2 angles. EGD is that angle right there, and DGH is this angle here. Those 2 angles form a straight line. The straight line they form is that straight line. Okay. When 2 angles are forming a straight line, they are said to sum up to 180 degrees. That is part of your angle addition postulate. I did not accept a reason of some people put a definition of supplementary angles. I don't know if those are supplementary. They haven't told me that. The only way that I know they add up to 180 is because of the way that they are orientated with one another. But once I know that those 2 things are equal to 180, going from step 11 to step 12, okay, those two things are both equal to 180 degrees. So let's just put those two things equal to one another. So that's what we did in number 12. The correct answer is transitive property. Transitive. But I accept substitution. It's transitive because if we look at step 11, this is an A um, statement, this is a B statement, this is a B statement, and then this would be C. So we have transitive as if A is equal to B and B is equal to C, then A is equal to C, and that's what we've shown. A equal to C. The next step was filled in for us, the definition of congruency. All they did there was they took step 13 and this part of your given and came up with 13 from that part of your given. If I knew two angles are congruent, then I know their measurements are equal. And the reason I had to say their measurements are equal is because we have a pattern that says if you have a sum of two things on one side equal to a sum of two things on the other side, see what you can remove from both sides. Something has to be equal on both sides. Measure of angle DGH and the measure of angle DHG are what we want to remove because we were told up here in the beginning that they are equal. All right. Or that their angles were congruent. So now I have to say that their measurements are equal before I can actually get rid of them. So I said their measurements are equal to the definition of congruency. Now that thing will cancel with that, and those things will cancel. And it'll leave me with just EGD equal to DHK. If I got rid of those, you can obviously see the EGD and DHK be the things that are left over. And when I remove something from both sides, that's the subtraction property of equality. Now that I have that, the angles are equal in measurement, I can say that their shapes are congruent, and that's the definition of congruency, going from equality to congruency. That's the only thing that changed. We got rid of the M, we got rid of the equal sign, and we made a congruency sign. That's the definition of congruency. So now you know in both these triangles an angle, a side, an angle, and then an angle, a side, and an angle. So you got ASA. And that was given for us, but we had to determine what triangles were congruent. Triangle EGD was congruent to triangle KHD. Moving on to the last one on the front. We've got FC, or not FC, EC congruent to GH. Okay, that was given here. Angle F congruent to angle G, and angle E congruent to angle H. If you recognize that you got segments overlapping each other, and we've talked about this in class, this is the common segment theorem. And I'm actually going to have you, instead of writing common segment theorem, you went through the process of actually showing the common segment theorem before you use it. But if I take EC and GH, they're the same value. They're said to be congruent. And if I take EC and add to it CG, and then I take GH and add to it CG, I get two new segments. Okay, I get this segment here, E to G, and I get that segment there, C to H. But because EC was congruent to GH, and I've added the same purple segment to both those yellow segments, the things I have in braces here, those new segments that we get, our results, should still be equal. If that still doesn't make sense to you, there are some proofs online in the section, in chapter 4 sections of showing the common segment theorem, and look through that proof again and just justify to yourself that that is true. They go ahead and tell us the first part where EC plus CG. If I start off with EC equal to GH, okay, those two things are equal, and I add the same thing to both sides, I should still get something that's equal. Okay, so that's just coming up with that new set of expressions. It's the addition property of equality. The next thing we do is we look at EG, just looking at EG by itself. They're telling me EG is made up of EC plus CG. But what is it when I get a larger segment equal to the addition of two smaller segments? That's the segment addition postulate. Okay. But they're asking over here, what if I did that to E to G, can I do the same thing to CH? So they're asking you, what is CH made up of? And we want to say that it is made up of C to G plus G to H. Now they're telling you use substitution. We've seen in the past. We're going to take these two statements and use substitution. I know that step 18, I'm going to rewrite step 18. Another name for EC plus CG, right here is EC plus CG. That is also known as EG now. So I write EG, and then rewriting CG plus GH. Well, CG plus GH, that's this right here. It's also the same thing as CH. So I'm going to write EG is equal to CH. And then going from step 20 to 21, all we do is change from distances to segment congruency. So that reason is definition of congruency. And now what we know, I'm going to highlight the segments. We know that segment is congruent to that segment. So now you've got angle, angle, side, angle, angle, side. So these two triangles are congruent by angle, angle, side. And now we can go one step further and say EF is congruent to segment HJ. And that's CP, CTC. Like I said, what these steps are a separate proof of what theorem? It's the common segment theorem. Okay. Going on to the back of the page. AB is parallel to EF, BC is parallel to DE, AD is congruent to CF. That's all you're given. We want to know, why is angle 1 congruent to angle 4? Well, if we look at our given, they tell us that this segment here is parallel to that segment there. Therefore, those two parallel lines are cut by transversal, so angle 1 and angle 2 are alternate angle 1 and angle 4 are alternate interior angles. So again, should say if two parallel lines are cut by transversal, then alternate interior angles are congruent. I'll just abbreviate. Going down to this part here, why is 2 and 3 congruent? Well, if I look at angle 2 and angle 3, those two lines are parallel, cut by that transversal. Now angle 2 and angle 3, those two angles are alternate exterior angles. So if two parallel lines are cut by transversal, then alternate exterior angles are congruent. Okay. The next part is telling you the common segment theorem. They're giving you the reason. Kind of walk through why they use that reason. We're given in the directions, or not in the directions, the given information that that segment there, A to D, is congruent to C to F. But what would be nice is if I could get rid of CD from both of those. Oh, I want to get rid of everything. Again, AD was congruent to CF, where if I could get rid of this little segment out of both of those, I could have A to C, which would be this side here, congruent to this side there, CF or DF, and that would give me then angle side angle. Well, if I know the yellow segment's congruent to the purple segment, if I remove the same thing from both and remove CD from both of them, I'm going to get a new yellow segment and a new purple segment, but those two things, since I started off being equal and I remove the same thing from both sides, my results should still be equal. All right, and that's the common segment theorem. So we want to say, what are those two segments that you would end up with would be AC congruent to DF. That's another example of the common segment theorem. And now I'm going to have angle, side, angle, angle, side, angle, so that's why these two triangles are congruent. Looking at this question here, we're given that AB is congruent to AC and AD bisects angle BAC. So that's your given. Now we want to look at the bisect part. We're bisecting angle BAC. So this angle here and that angle there become congruent because of the angle bisector, the definition of an angle bisector. So it's angle BAD is going to be congruent to angle CAD. From there, filling in the things we do know, we know that and that. From there, it'd be nice if we knew this middle segment congruent to itself, and that's what they're leading us here to say AD is congruent to AD. That's the reflexive property. So now I've got the triangle on the left congruent to the triangle on the right. So, and it's by side angle side. So now if this triangle here is congruent to this triangle here, then corresponding parts, such as that angle and that angle, have to be congruent as well by CP, CTC. Going down to the next one. Obviously, your first information is given. First period, you guys had this CD congruent to CE. Later in the day, I crossed this out for everybody. Number one was given. So what we need to do, they're talking about segment AE and segment DB, okay? If we're to highlight them, they're these segments being congruent. So what I'm going to do is, because those segments come from triangles, I'm going to tear apart the triangles that they come from. And my pictures aren't going to be very good here, but you get the idea. This triangle, let's call that AEC. So I'll highlight over here which triangle we're talking about. There's AEC, and then I'll call this triangle here, it's going to be D, that'll be B, and that'll be C. This would be angle 2, and this would be angle 1 if we tear those triangles apart. Given the given information, we know this segment is congruent to that segment. This angle is congruent to that angle. Okay. It would be nice if we could figure out that side there congruent to that side there, because then I'd have side angle side. We'll come back over here and look at this middle triangle. If I look at that middle triangle, you are told that angle 1 is congruent to angle 2. So if those two angles are congruent, you should know that the side opposite that angle and the side opposite that angle should be congruent. So CD is going to be congruent to CE. And the reason is the converse of the isosceles triangle theorem, which says if two angles of a triangle are congruent, then the sides opposite them are also congruent. So now, CD is this segment here, CE is this segment here. So now I do know that those two triangles are congruent, ACE and triangle BCD, by side angle side. And now if that's the case, then AC, that segment there, and CB or BC, that segment there, are corresponding parts. So CP, CTC, they're congruent. And now if they're congruent, if I were to highlight those segments over here, here's AC, here's CB. We just said that those are congruent. Well, then that's going to make that whole triangle ACB and isosceles, or ABC and isosceles triangle, by the definition of isosceles triangles. This question here, second to last, you are given WX, that's perpendicular to YZ, and angle 3 is congruent to angle 4. I want to prove these triangles congruent, so that's your given. I'm going to look at the vocabulary, and it's perpendicular, so I want to say angle WXY, that angle right there, and angle WXZ are right angles. Okay, now I had to name them by 3 letters, because if I just said X, you don't know what angle X, you don't know if I'm talking about this one on the left or this one on the right. So this is the definition of perpendicular lines. That's what provided me with the right angles. Once I have right angles, I'm going to say that those right angles are congruent. So angle WXY is congruent to angle WXZ. Reason being all right angles are congruent. So I've got that congruent to that. The given said this was congruent to itself. Now hopefully you guys recognize that WX, that segment, should be congruent to itself as well. That's your reflexive property. So now I've got angle, side angle on the triangle on the left, angle, side angle on the triangle on the right. So I now said those two triangles are congruent. Triangle YXW is going to be congruent to triangle ZXW by angle, side angle. And the last question, you had seen this last week in our quiz, so hopefully we did better on this one than we did on the quiz. Obviously you want to write your given, so AB is congruent to CB, and BM bisects angle ABC. Given. We're going to look at my given information. There's a vocabulary word in there. It's bisects. BM bisects that angle right there. So the two angles that are created are angles 1 and 2. So angle 1 is congruent to angle 2 by the definition of an angle bisector. So I've got that congruent to that. And now you recognize, hopefully, that BM is congruent to itself. So BM is congruent to BM, which is a reflexive property. Step number 4, now that you've said that, you've got side angle side in this triangle right here. You said that you can say that that triangle is congruent to that triangle. So I've got triangle ABM congruent to triangle CBM by side angle side. Once you know that those two triangles are congruent, then you know that all the other parts of the triangle are congruent, okay, or corresponding parts. So if that triangle on the left is congruent to the triangle on the right, you should know that those two segments are corresponding parts. So I can say AM is congruent to CM by CPCTC. You can also kind of remind yourself, well, A is the first letter here, M is the third letter, and then C is the first letter, and M is the third letter. So they do correspond in terms of the name as well. And now that I know that this segment here is congruent to that segment there, that's going to have to force AMC, that triangle, to be isosceles. And the reason is definition of isosceles triangles. Okay. Each one of these questions was worth 1 point all the way up to question number 38. So for example, 35, a point for there and a point for over here. And then this question was worth, let me see here, I believe I put it as 5 points. Okay, so I made a statement worth half a point and a reason worth half a point, and then this one was worth 6 points. If you have any questions about any one of these, make sure you come see me. I have no problem going over any one of these with you guys. Remember, if you're going to do the retake, to watch this video, maybe watch it 2 or 3 times. Go over these questions. Don't just sit there and watch it. You got to actively participate. So as we do one of these, I'd freeze it, pause the video before we start doing it. Do it with a piece of paper, on a piece of paper by yourself, and then once you complete the proof, then hit play and see if your proof ends up matching up with my proof. And then if it doesn't, make sure you determine why it doesn't and get your misconceptions fixed. Don't hesitate to come see me.